All right, we're doing Chapter 8, Section 4, which is Learning Plan 4.9, and we're going to add and subtract radical expressions, which is kind of like adding and subtracting polynomials. In other words, you can only do it if the parts that you're adding and subtracting are the exact same. If you notice, oops, why did that do that? If you notice here, oh no. Let's go back here and see why we can't. Okay, well, we'll just do it this way. These radicals are the exact same, so 7 plus 3 is 10 roots of 5. Now, the deal here is you might not think these are the exact same, but remember, 44 divided by 11 is 4, divided by 2 is 2. So this is the same as a pair of 2's on the outside, but since there's already a 3 there, 3 times 2 root 11, which is 6 root 11. So you have 2 minus, remember this is a 1 in front, so 2 minus 1 is 1, plus 6 is 7 roots of 11. So in this case, you would take the 12 divided by 3 is 4, which is 2 root of 2. 75 divided by 3 is 25, which is 5 and 5. So this is 5 times a pair of 2's, which is 10, root of 3y, plus pair of 5's times a 6 is 30, root of 3y. 10 and 30 makes 40, root of 3y. Down here, you might think you'd be able to do something with that, but you can't because 10 is 2 times 5, which doesn't have any square roots in it. So this is as simplified as it gets. When you're ready, I'll show you how I did these. For the first one, you've got 12 divided by 3 is 4, divided by 2 is 2, so that's 2 root of 3. 75 divided by 3 is 25, which is 5 and 5. So plus 5 roots of 3 is 7 root of 3. And change colors. 63 divided by 7 is 9, which is 3 root 3. So negative 3 root of 7t plus, and now let's take 28 divided by 7 is 4, which is 2 times 2. So there's already a 3 out front, times 2 makes 6 roots of 7t. Negative 3 plus 6 is positive 3 roots of 7t. For the last one, you can't simplify because there's nothing that they have in common. Okay, so you do this one. Now, the square root of 8 is 2 root of 2, but there's already an 8 out front, so that makes this 8 root of 2 plus, and then this part becomes 16 root of 2, which is 24 root of 2. Remember, there's a difference between root of 9 plus the root of 16 and the root of 9 plus 16. Okay. I think the easiest way to look at this one would be to see that this is 2 to the 5/4. Now let's just do it the other way. Okay. 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. We've got one group of 4 2's, but we already had a 2 on the outside, so that's negative 4 root of 4, and we still have a 2 left on the inside. 162 divided by 2 is 81. Divided by 3 is 27, divided by 3 is 9, divided by 3 is 3. So we got 7 on the outside times another 3, so minus 21 fourth root of 2, because we still have a 2 left, is negative 25 fourth root of 2. I like doing letters better than numbers. Let's look at the 64. 64 divided by 4 is 16, divided by 4 is 4, so we have a group of 4 on the outside. And this first part is p on the outside, q squared on the outside, cube root pq, minus 4 cube root pq is pq squared minus 4, and then the cube root of PQ, which isn't really that much simplified if you think about it. But I think the part they want you to notice is these two they have in common in both parts. I think that's why that's so important. Okay, let's try the next one. Cube root of 16, well, 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. So that's 3 2's on the outside, but there's already a 6 there, so that makes 12. And then z squared, and we still have a z left on the inside and a 2 left on the inside. So for the next one, we better have a 2 and a z left on the inside for that, too. Oh, this is a cube root. Okay, so square root of 200, 200 divided by 2 is 100, divided by 10 is 10, so that's a pair of 10s on the outside, but there's already a 4, so that's 40, z squared, square root 2z, 2z. Now remember, this is 12z squared 2z to the, what would that be, 1/3 plus 40z squared 2z to the 1/2. Let's get both of these to the same denominator. So that would be to the 2/6, and this would be to the 3/6. Two six plus 3/6. I don't know that we can simplify that very much. Hey, look that one in the book to see where they got that from. What they wanted us to do in our book. That's on page, let's see here. Example 2 is on page 454. Let's see, cube root. Oh, yeah, we can't simplify it anymore. We just have to leave it the way it is. 12z squared plus 40z squared, and then 2z to the 1/3 and 2z to the 1/2, or just square root like we had here. Okay, next one. All right, so if you look at this first one, 2,000 divided by 2 is 1,000, divided by 10 is 100, divided by 10 is 10. So you got a group of 3 tens on the outside, but there's already a 3 there. So that's 30 cube root 2. And then 128 divided by 2 is 64, divided by 4 is 16, divided by 4 is 4. Another 3 4s on the outside, but there's already a 4 there, so 4 times 4 is 16 cube root of 2. 30 minus 16 is 14 cube root 2. For letter B, I'm going to go to this one. The first one is 5a fourth root. There's still an a left on the inside and a b cubed left on the inside. Oops. Plus fourth root of 81 is 3. And then the a stays on the inside. The b squared is on the outside. B cubed. So you could rewrite that as 5a plus 3b squared, fourth root, there, I forgot the 4, ab cubed. The last one, you could probably the book's got it wrong. Oh no, there's not a b squared. You can only take a b out of the inside. Not a b squared. Okay, last one, and change colors again. 128, the cube root of 128, well, we just did that, is 2. And then there's a cube root 2 left on the inside. T is on the outside. T is on the inside. Minus square root of 72 is 72 divided by 2 is 36. Divided by 6 is 6. So 2 times 6 is 12. T square root 2t. All right. How about this one? The fourth root of x to the 7 is x. There's already an 8 on the outside. Fourth root x cubed minus 5x. Fourth root x cubed. 8x minus 5x is 3x. Fourth root x cubed. All right. Now, if you have a fraction like this, remember that you can take the square root of the denominator, and that's 2 root 32 over 6. Now, square root of 32 is a pair of 4s on the outside, but we already have a 2 on the outside, so that makes it 8. Square root 2 over 6. I'm going to leave that for right now because I might need it for my common denominator. Now, if you do 108 divided by 4 is 27, divided by 9 is 3. We have one pair of 2's here, one pair of 3's here, so we have to multiply the top and bottom here by the square root of 3 to get rid of this denominator. In other words, we're really doing this, the denominator 324. 3 times 108 is 324. 324 divided by 2 is 162, divided by 2 is 81, divided by 9 is 9. So we have a pair of 2's and a pair of 9's, which is 18. So plus 2. This is over 18. And then the numerator is 3 times 27, which is 81. The square root of 81 is 9. 2 times 9 is 18. 18 over 18. So our answer is, let's simplify this, 4/3 root of 2 plus 18 over 18, which is 1. Now I suppose we could write this as 3 over, and then put the whole thing over 3 also. It doesn't matter which way you write that one. Okay, how about this one? Well, the square root of y to the 4th is y squared. Square root of 80 divided by 2 is 40. Divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. 2 pairs of 2's, which is 4. Square root 5 plus, this is y to the 5th, and square root of 81 is 9. Now, do we want that all over one denominator? If we do, then we have to multiply the first part by y to the 3rd over y to the 3rd. So we get 4y cubed root 5 plus 9 all over y to the 5th. See how we had to do that so that we got the first part over y to the 5th also. I'm not sure if that's simpler, but that's the way the book wants us to write them. You do these two. Well, the square root of 45 is a pair of 3's on the outside, but there's already a 5 there. Well, let's leave that on the top. So it's 5 root of 5 over 3 root of 5. These cancel, so you have 5/3 minus root of 9 is 3, and 28 divided by 7 is 4, which is 2 times 2. Root of 2 2's makes this an 8, root of 7. So we have 5 minus 8 root of 7 all over 3. For the other one, x to the 12th, the cube root of x to the 12th is x to the 4th. Cube root of 16 is 2 root 2 cube root 2, but there's already a 6, so that makes it 12 cube root 2 plus cube root of x to the 9th is x to the 3rd. Cube root of 7 is, or of 9, so it's 7 cube root 9. The only way we get common denominator is to multiply this second one. Multiply the second one by, I'm going to change colors here so that you see, x over x. So we have 12 cube root 2 plus 7x cube root 9 all over x to the 4th. Try this one. Okay, to get rid of the denominator here, you're going to have to multiply top and bottom by 3. So you have the square root of 6 over 3. 18 over 27, you have to multiply top and bottom by 3 again, and you have 50, square root of 54 over, this is 81, square root of 81 is 9. So you have the square root of 6 over 3 minus, this is, if you divide that by 6, you have 9. So this 3 root of 6 over 9. But you can simplify this to get a 3 on the bottom. Square root of 6 over 3 minus the square root of 6 over 3 is 0.